Hello everybody, welcome to our first online lesson. I know things are going to be a little bit bumpy at the start for both me and you, so we're going to get started with some review. Make sure you remember everything after 2 weeks off. We're going to get started with the beginning parts of Chapter 9, then we're going to move on to the last parts of Chapter 9, the final parts, next week. So we're going to jump right in, get started with our review of Section 9.1. And what that was quadratic graphs and their properties. Quadratic graphs and properties. Now, like always, we're going to get started with a start thinking. Let's see how many of you remember this. What is the standard form of a quadratic? Well, our standard form, remember, is y is equal to ax squared plus bx plus c. We're dealing with quadratics. The important part was we have that x squared. And so we have some constant or some coefficient, x squared, plus something times our x term, plus just our regular constant. This is the standard form. We also had something else important. We called it the parent function. So the parent function is the most basic form of the quadratic. The parent function is the most basic form of the quadratic. And that most basic form, right, if we had nothing else, what makes this a quadratic is our x squared. So our parent function is y is equal to x squared. And we had a special name for the graphs. When we graphed these, we didn't call them quadratics, we called them parabolas. A parabola just looked like some sort of U, whether that was smiling or frowning. So our standard form, ax squared plus bx plus c. We have our basic form, our most basic form, the parent function, which is y is equal to x squared. Then we also know that our graphs are called parabolas. Those are the ones that looked like U's. We had a couple of special parts of the parabolas, so let's go through those. Right? If we have some parabola here, say it looks like that. The first thing we had was called our axis of symmetry. And so our axis of symmetry is the line that divides the parabola into two matching parts. Remember, if we try to fold the parabola, this would be what we folded on to get matching parts. So it's the line that divides the parabola into two matching parts. If we were looking at that for this, our axis of symmetry would be somewhere right about in there. So our axis of symmetry is the line that divides it into two parts. We also had what we called a vertex. And our vertex was the largest or smallest point and it was also on the axis of symmetry. So if we're looking at this, our smallest point, if I had drawn this properly, it's going to be somewhere in there. We could figure out what the value for that is, and our vertex would be that ordered pair. We had two more special bits. We had something we called a domain. What your domain was all x values, right? All inputs, not x inputs, x values, the graph can take. So, right, we're looking at this. Our domain is anything it looks like our graph can take. So in this case, it looks like our graph with those arrows will go out all ways, both ways. The other one, or the matching one we had for this, was our range. And our range was all y values, or outputs, that the graph can have. So if we're looking at this, right, we have some smallest point here, and it goes all the way up. So our y values, or our range, are the points that this can take, right? We go from bottom all the way up to the top. Let's do a bit of a practice here. We'll go through an example, a refresher, which is what we have here. We're going to look for the axis of symmetry, the vertex, and the domain and range. So if we're looking for this, the axis of symmetry, the part that makes this fold into two, looks like is right here. So our axis of symmetry is the line x is equal to 1. Where's our vertex? What's the smallest or largest point we can take? Well, it's right there, right? It's on the axis of symmetry, and we're looking at that. Our vertex is the point, our x value is 1, and our y value is -1. What's our domain? Well, it's all the x values, so we know we have at least those x values, but those arrows tell us that continues that way, and it continues that way. So our domain was, and this is an interval notation, remember we had to do that, put the smallest value first, -infinity, goes all the way out this way, and it goes all the way out to +infinity. And finally, we have our range. Our range, right, we start with all the y values this can take. And we have a smallest one right there. But looks like everything goes up. We can keep going up. So our range is going to be, well, we start at the smallest value, which is going to be -1. Remember, we include that in blocks or in a bracket there because this value is included, and we go all the way up to infinity, which we close off with a parentheses. So make sure you have those 4 definitions down and you remember what they are. We have our axis of symmetry, we have our vertex, we have our domain, and we have our range. Now I know there might be some questions. If you have any questions, make sure you're emailing me, or make sure that you are actually setting up times or coming into the office hours that we'll be setting up. Right. So those were the basic parts. Now we talked about a couple of things that can change what happens with the parabola. Specifically, we actually had 2 of those. The first one of those was a. Let's talk about what a changes. Remember, this is the a from ax squared. What happens when we have that a? Well, if a was positive, then we knew that our parabola opens up. Sorry, move that graph down a little bit so we have some extra room. So, if a is positive, the parabola opens up, right? We look at this, we make it, it opens up. And what does that mean? Well, our vertex, which is our largest or smallest point, is the smallest point. So our vertex is a minimum. What about if a was negative? Well, then the parabola opened down, right? It was frowning. And what happens if the parabola opens down? Well, our vertex, our largest or our smallest point, is the largest point, right? It tops off the graph. So our vertex is the maximum. If A is positive, it opens up. If it's negative, it opens down. Now we also had two other things that the A value could tell us. The first of those was that if A was small, right, absolute value of A is less than 1, which is just saying A is a fraction or a decimal, then we had A is greater than 1, excuse me, right? So if we had a large value, then our parabola was narrow. Remember, you can test this out in your graphing calculators. Remember that, make sure it all makes sense. So our parabola is narrower. And if A was less than 1, right, if we had just a decimal or a fraction, then the parabola was wider. We actually can do sort of a basic graph here, right? If we have values close to 0 and going all the way up to numbers that are close to infinity. So if we make our line here, they'll be wider on this end and narrower on this end. And we can throw some examples in, right? Negative 1/4 x squared would be pretty wide, but 1/2 x squared would be a little bit narrower. X squared would be somewhere in the middle. And we could keep going up, right? If we had 3x squared, that would be even narrower. If we had negative 7x squared, that would be even smaller still. So A, remember, it tells us whether the parabola opens up or down, depending on whether it's positive or negative. And if it's larger than 1, if it's a large value, our parabola gets narrow. And if it's a small value, our parabola gets wider. We had one other important value. Oh, let's move that down again. And that was the value c. This was from ax squared plus bx plus c. And all c told us was it moves the graph up or down. It tells us something a little bit more important in a later lesson, but remember, c moves us up or down. So that was section 9.1. Now, homework from here on out is going to be based on whether or not you got these problems correct. So I'm going to give you some practice problems, make sure you remember this, and then you can move on and start the homework. So, we have some practice problems here. First of all, we have this graph. I want you to tell me the domain, the range, and the vertex of this graph. Then I also want you to tell me how is y is equal to negative 3x squared plus 2 different than just our parent function, which is y is equal to x squared. Finally, we're going to look at a couple more problems, right? We're going to ask which one of these is going to be the widest and which is the narrowest. So we're looking at whether 1/3 x squared is the widest, whether negative 1/10 x squared is the widest or the narrowest. We're looking at if 4x squared is the widest or narrowest, and if 8x squared is the widest or the narrowest. So pause the video, actually work through each of these, see what your answers come out to be, and then meet back with me after you finish those. It's important that you actually pause now. So, pause. I mean it, pause. Okay, let's get back to these. We're looking at this first one. We're looking for the domain, the range, and the vertex. So, the domain, we're looking for all the x values, right? We're looking for all possible x values this can take. And we look, covers all of these, but the arrows tell us it keeps moving on and on. So, Our domain is negative infinity to positive infinity. What's our range? Well, the range is the y values. It's all the y values this takes. So we start here and we go up. The arrows tell us we keep moving up. So our range starts. What's our smallest value? It's -2, and it goes all the way up to positive infinity. Then finally we have our vertex, which is going to be the smallest value here, right there. So what's our vertex? Well, our x value is -3, and our y value is -2. Right. Looking at this, we ask, how is y is equal to -3x squared plus 2 different than y is equal to x squared? Well, we have our a value, right? So we know that a is negative. What does that tell us? Well, we open down. So the negative tells us we open down. What else has changed? Well, we have that 3 out in front. 3 is larger than 1, so this tells us we're going to be narrower than the original function. And the plus 2, right, that's our c. C moves the graph up or down, so this gets moved up 2. And then for problem 3, which one of these is the widest and which is the narrowest? We have 1/3 x squared, -1/10 x squared, 4x squared, and 8x squared. The widest one is going to be the one that's closest to 0, the one that's the smallest fraction. So the widest one is going to be -1/10 x squared. Right? The -1/10 is smaller than any of the rest of these. The narrowest is going to be the largest value, the one furthest away from 0. And in that case, this is 8x squared. So there's your refresher on 9.1, quadratic graphs and their properties. Go ahead.